Today, in my first lecture, I would like to discuss some of the simple method of synthesis of metallic nanoparticle. In my earlier classes, I have already discussed the fundamental theories behind the synthesis of nanoparticles. I have discussed about the homogeneous nucleation, I have discussed about the heterogeneous nucleation, as well as the growth and ultimately the post-Wald ripening and formation of size and shape controlled nanoparticle. But today, what I am planning, I will discuss some of the very important and useful metallic nanoparticles. Now, before I start my discussion, I must tell you that again the chapter is very broad, subject is very broad, but as per our syllabi, M.Sc 4th semester, I have divided the nanoparticles in 4 important groups. You have to study not only the metallic nanoparticles, but also semiconductor nanoparticles. And in semiconductor nanoparticles, we will concentrate metal oxide as well as the metal sulfide, which is very important. And recently, as I told you, that recently from this year, we have introduced carbon-based nanoparticles. Why? Because in our department, large number of teachers as well as the students are working on carbon-based nanoparticles. Like they are preparing graphene quantum dots, carbon quantum dots, as well as the different types of dope, co-dope quantum dots. And you must know some of the elementary ideas about the organic nanoparticles, which is very natural nanoparticles like flyvosomes and ferritin. And ultimately, we will discuss the ceramics. So today I will only concentrate on the metallic nanoparticles. Now, as you know that very common method of this synthesis of the nanoparticles, one is top-down method, another is the bottom-up method. I will not discuss the advantages and disadvantages of this method, but basically being a chemistry teacher, I must concentrate on the bottom-up synthesis of metallic nanoparticles. And you must know that our main objective is that sometimes you can call it a tailor-made or size and shape control nanoparticle. So everything is important. The concentration of the precursor, concentration of the reducing agent, as well as sometimes that stabilizer or capping agent, as well as the pH also plays a very significant role for the size and shape. And one of the most common method is the sol-gel method. Today I will not discuss the sol-gel method, but now you can ask me, sir, there are a large number of metals or some transition metals, but why you are concentrating on a few of the metallic nanoparticles? The answer is that depending upon the application, we do synthesize the metallic nanoparticles. And if you see the literature, you will find that most widely studied nanoparticle is gold and silver. I will also show you one of the methods of the copper nanoparticle, but it is very, I am not saying that copper nanoparticle is very difficult to prepare, but in comparison to silver and gold, it is a little bit difficult. And there is a large number of application in platinum and palladium. You know that is one of the most important catalysis. Then you can sit here so that the student can. Like molybdenum are also very important. So first I will explain the platinum and then of course the rhodium and other things of the things. Okay, so these are the reason for choosing different types of nanoparticles. Now, as you know that there are basically two approach, and as per the examination point of view, you cannot restrict only one system. So what I suggest my student that you should also learn sometimes I'm not this lecture I'm avoiding all this type of lithography and top down approach, but rather I am concentrating on the chemical reduction method. And most of our departmental lab, they are using the hydrothermal methods, sol gel method is also working. But today in this short lecture, short presentation, I will only concentrate on the chemical reduction method. And another method is also very important, that is called the, I think I have not written here, that is called the electrochemical reduction method, electrochemical method, that is also very important. And that day one of the students, he has discussed about the green synthesis, but in this lecture I am not including this green synthesis, and in our prospectus also. Basically nowadays due to some green chemistry, scientists are using the green synthesis. Unfortunately, most of the plant extract, it can be part of the root, it can be part of the stem, leaves, even fruits, can also be used for the green synthesis. And microorganism is also plays a significant role, like bacteria or algae and fungi. So I will not concentrate only on the green synthesis. I will just concentrate only on the chemical reduction method and only metallic nanoparticle. So according to the literature data, metal nanoparticles can be synthesized by various methods, but chemical reduction methods are most applied and simple method. Therefore, I have chosen only the chemical reduction method, and I have taken all this method from the literature. Some of the research papers I have already mentioned, I will also mention their names. So it is up to you. You can follow all this method, or you can search the literature and add as much as more method you can include. But I am using some of the simplest method. And the first method, I think I have already discussed. Again, I just want to tell you that I will not show you the experimental setup, types of the beaker or types of the flask and other things, or stirrer. No, I am just concentrating only on the chemical reactions and other things. And this is sodium borohydride is one of the most common reducing agents. So it is, now you must recognize that one is precursor, another is the reducing agent, and third is the capping agent or stabilizer. And in my previous class I also discussed you that sometimes it depends upon the types of the reducing agent. Size is also sometimes depends upon this reducing agent. So one condition is that the concentration of silver nitrate must be very low, around 2 into 10 to the power minus 4, very low. So the initial synthesis of silver nanoparticle was assessed through the visual color, because whenever a student do start the nanoparticle, I ask the student, just first you prepare the silver nanoparticle and show the color. And I remember long back, I think 10 years ago, that time also they have not started the nanoparticle work like Manmohan. So I have given one objective to my student, Sanchita Banerjee. Yes. So she prepared first nanoparticle, silver, known method. So very nice yellow color observed, and then we do the UV visual spectra, and then we confirm it is nanoparticle. But as I told many times, that size and shape control is most important, and it is a simple reduction, silver plus to silver 0. Another method is also there, that it should be 10 to the power minus 3, like that. So This is silver nitrate and citric acid. So it will form the silver. And so why I am showing these things? Because sometimes what happens that this is the most simple method. There is no pH control is reading, but sometimes you have to boil this solution till we get the yellow color, and we measure the spectrum. And if it is get at 400 nanometers, then we thought yes, initial. There are now same and tame and other XRD method, but initial system is that visually you can, for whether it is a silver and gold, you can understand that this is yes, the correct nanoparticle is produced. So 100 ml of silver nitrate, 10 to the power minus 3 or even 10 to the power minus 4 was heated until the boiling, then 4 ml of 1% of sodium citrate solution, and mole ratio may be 1:4. No pH control is required. You will get the simple silver, and it can be used for any catalysis process, for sensor process and other things. Now another method is very important. I think there must be some error. Because yesterday I have prepared, I am not expert in just prepare how to prepare the transparency and other things. This is also very important method. Suppose you want to prepare silver nano in a very good quality and pure form. So what we do, we eliminate the acetone first, and then this acetone, excited state acetone, is react with the isopropanol, and it forms the ketyl radical. You see, ketyl radical, and then this ketyl radical sometimes converted into ketyl radical anion, and then this both are responsible for synthesis of the nanoparticle. Even a ketyl radical as well as the radical anion can also prepare the. So it is a very good method. So first, this is the acetone, excited state, just UV, we have a UV lamp, just excite the acetone, add some ethanol, 2-propanol, and it forms a radical. And then automatically it undergoes a proteolytic dissociation and form radical anions. So you see that. So temperature is not important here, nothing is important, so we can prepare the very purest form of silver nanoparticle. In addition to that, there is a electrochemical reduction method. I will not include it in this lecture, but after this lecture I can show you that electrochemical reduction of the silver method. But this is most common method. Now second, I am coming to gold. I think it is very important method and very simple method, but if you see the literature, you will see that there are a large number of methods, and basically we can use the chloroauric acid or even simple gold electrode. We can see like silver nanoparticle is yellow in color, and you can see the color of this gold nanoparticle. But basically we use a very old method. I think 1970, that scientist, he actually discovered, in fact not discovered, he studied initially the synthesis of the gold nanoparticles, and then nowadays actually most of the scientists are using the green synthesis, Brust and Citrin method, but same thing. But the problem is that that there are many oxidation states in the gold, so we should be very careful while using such type of reducing agent, but ascorbic acid or sodium borohydrate. I will show you two reactions. Most of the places we use the precursor, the chloroauric acid, and you know that there are so many oxidation states. So It is just like a reduction process to convert it into the gold zero state, and the gold zero is the final state for the nanoparticle. So the major step involving the synthesis of gold nanoparticles is reducing, first is A+1 or A32A0 by adding an electron donor, that is the reducing agent in the reactions. So the chemical reduction can be performed using various chemical reductants such as sodium citrate. We can use the hydrazine, we can use the ascorbic acid, sodium borohydrate. But when you compare the gold and silver, so my advice is that you must use some of the capping agent, and in our lab basically we use the surfactant like cationic surfactant, cetyl trimethyl ammonium bromide, and you can also use some polyvinyl alcohol like that. So one condition is that we should take this very dilute solution of this chloroauric acid, 2 into 10⁻⁴ m, dissolve into water, make 20 ml, 1 ml of 0.5% sodium. It depends upon the, don't follow exact system, it is variable system, but condition is that the solution should be very dilute. Now I am taken this very recent article. Why I would like to show this recent article? Because you know that 1970, today is 1923, 2023, but still scientists are, and Analytical is a very good journal, still, and it is a review article, you see 250 to 60, 13 pages. So it is a very big article, and because nowadays it is not like that just you add the reducing agent and just convert it into the gold nanoparticle. So still scientists are working on the nanoparticle synthesis, and this is one of the example. Now see here the same thing, that first there are two steps. First you see that reduction in the with the help of the citrate. This mechanism involves two steps. Trivalent gold is reduced to monovalent gold. Simultaneously citrate is oxidized to acetone dicarboxylate. This is the second step, involves a disproportionate reaction in which metallic gold should be a zero and trivalent gold are produced. The overall reaction is shown in figure 5. So similarly, I will show other method also, that large number of good methods are available in the literature. But basically you can call it is a simple reduction process. But because there are two oxidation states, the first one is converted to one oxidation state, then like that. Again I am showing in another very, not very recent paper, but you can ask me, sir, what are the factors? How the size and shape of the nanoparticle is dependent on the condition, pH, concentration of the reducing agent, types of the reducing agent. Therefore, I am just showing you one of the, just a glimpses of this paper. I will not discuss the details of these things, but again it is also a very good journal, American Chemical Society journal, published in 2021. So the synthesis of gold nanoparticle is dependent on both the concentration of trisodium citrate, that means reducing agent, then the time is also important. Suppose the boiling time is 15 minutes or 20 minutes or 25 minutes, as well as the pH. In this model, the pH of the solution decreases slightly throughout the reaction due to the chemical interaction between the trisodium dihydrate and tetrachloroauric acid. Same mechanism, dicarboxyacetone is also formed, everything is same. But see, with the help of zeta sizer, they also identify the size of the things. You see that this is actually research. You see, they are generally we get max, lambda max is 520 like that. You see how, because this is research oriented teaching, that means although 519 nanometer. So what is the difference between 519, 520, 521, 522? For a layman it is just same thing, 19, 20, 21, 21. And you see the time, suppose 10 minutes, then 30 minutes. One of the condition of that nanoparticle is that it must be very, very stable, and there is no agglomeration. So although there is a very slight change, but it is a research. So I cannot say that time is very important factors, because there is very minute change, 519 to 520. So that means you can say that it depends upon the, even size is also, you will say the, suppose it is 20 nanometer, the size is 18, 20, very small, 18, 22, like 18 to 22. So, but it plays some role, not very significant, but, and it is also very new paper, 2020, 2021, 2020. What I mean to transmit to you that it is a very simple thing, but still scientists are working on the synthesis of the metallic nanoparticles, and they sometimes do very slight modification. And there is a tremendous application of this gold and silver. Now I am coming to the rhodium. You all know that rhodium is one of the most important, rarest and the most costly metals. So generally, of course, there is also reduction, but things is that in our department we are not doing the rhodium, because rhodium chloride salt is very costly, but system is same. It is also reducing agent. Only thing is that we have to reflux it for 16 hours like that. So in the presence of methanol and water, 1:1. Temperature is very high, 80 degrees centigrade, and the stabilizer or capping agent is polyvinyl alcohol, just for stability and other things. So methanol is used as a reduction agent, and PBA polymer is a stabilizer. This is the equation. Now I am coming to the palladium. These are all simple methods, although if you search the literature you will get many other methods, but sometimes as I told you that in examination time you will see the old question paper, what is metallic nanoparticle, how metallic nanoparticle is synthesized, how metallic nanoparticle and semiconductor nanoparticle is synthesized. So at least you have to write 4 or 5 metals or transition like that, not more than that. So in palladium also slight difference is that formation of, first there is a hydrolysis of that precursor, and then that hydrolysis process, that hydrolysis product reacts with hydrogenation and the formation of the palladium. You can ask why you are using the sodium carbonate. Sometimes what happens, I will show you after that a simple method. For platinum, we use actually methanol, and in first step there is a large formation of the chloride ions. So that chloride ions sometimes acts as a catalyst, and that will increase the monodispersity of that metallic nanoparticle. So sometimes it will be useful for that. So here this sodium carbonate is used as a catalyst. So it reacts with, first is a hydrolysis process, and then is hydrolysis react with this hydrogen and formation of the palladium. So Any student can write this thing. It's a very, very simple method. And again, I am saying that why such thing is very important. Sometimes you know that nanoparticle synthesis is a very fast reaction. Sometimes what happens. So again, I am showing you one of the very good journals, that is colloid and surfaces A, and the synthesis of palladium nanoparticles using continuous flow method. So same thing, nothing new. It is two reactants. One is reducing a sodium borohydrate and palladium chloride. So just both the solution are forced to place in this reaction vessel, and ultimately will form this palladium nanoparticle. What I mean to say, that means there are a large number of literatures available. So it is up to you that how you prepare the notes on the synthesis of the metallic nanoparticles, and it is not at all difficult. Everywhere you have seen, because as I told in my introductory part, I am concentrating only on the chemical reduction method, although there are many methods. Now I am coming to the again last, I think it is the platinum nanoparticles, because there is a tremendous use of this platinum in biological system or in the medicinal chemistry. So there are so many methods. One method is platinum nanoparticles are typically synthesized by the reduction of the platinum ion precursor. Of course, we need some capping agent, but for silver and gold, for silver I don't think any, because they're very common. So these are some very common precursor: potassium hexachloroplatinates, platinous chloride, chloroplatinic acid. So you see, here is also, sometimes I will show you the another method, that PTCl62. First step is the hydrolysis process, and again you see, as I told you, that there is a formation of the chloride ion, and this chloride ion sometimes promotes the monodispersity. So the first is the hydrolysis. So there is a formation of the aquated complex, and this aquated complex will be reduced by hydrogen, and we use a sodium polyacrylate stabilizer or capping agent. So you see the size is very good, only 7 nanometer. Before I just another method. Is there any pen? No pen is required. Okay, no problem. So the role of chloride ions. So if we take a platinum, it's converted into water. What do you mean for that? What is important? And that is actually I think there is a, oh, I am sorry, that need a methanol. Reduction agent must be there. Yes, I'm sorry. methanol. And it is converted into formic acid, HCH. My objective is the roll up, and then is also some excess methanol from platinum, again HCHO, hydrogen, that's 4 here. So question is that it's a very simple method, only we can use the methanol, but what happened, this chloride ion promote the monodispersity. It is a very modern method for like that. So now I am coming to the copper. Last method is copper, and you will realize that it is also, I have taken from a literature, a very recent literature, 2023, and journal is also very good, Royal Society of Chemistry, RSC Advanced. So don't worry to see all this very big picture. I will explain step by step. But basic principle is same. Synthesis of copper nanoparticle using a reducing agent and a capping agent, nothing new. But in order to get size and shape control pure copper nanoparticles, we have to do certain additional exercise, because there are some products that are metastable intermediates. So same thing, we have taken this some ethylene glycol and precursor is UCl2. Every time we need things, and the reducing agent is the ascorbic acid. So we will heat this thing, then after 10 minutes heating, we will again dilute it, stirring it, again we add some ascorbic acid and sodium hydroxide, and ultimately we will get the copper nanoparticles. I have taken this, I have already told you. Now I am read out there why these 2 steps are important. There are 3 steps also. I have not included that step number 3. Firstly, a certain amount of ethylene glycol, anhydrous copper chloride and PV were wet. The ethylene glycol was added to a beaker, and then PVP and anhydrous copper chloride were added. Just a simple method. Molar concentration of copper 2 is 0.37 molar. And the amount of PVP, that means same thing, we are just adding all these things. Temperature is, but what I mean to say, or what I want to show you, that in comparison to silver and gold, it is slightly difficult, because some of the intermediates are very unstable. So up to first step, we mix all the items gradually, but ultimately ascorbic acid is the last and final step. So what is the second step? The dried intermediate product, we may understood it may be copper nanoparticle, but we dilute it with the 10 ml of deionized water. Then again we add some sodium hydroxide solution, some ascorbic acid solution using deionized water as solvent was prepared. The beaker B was then heated, again we have to heat it, stirred for 30 minutes, then the sodium hydroxide and L ascorbic acid solution were poured into the beaker. After dropping at room temperature, the copper nanoparticles were obtained, by centrifuging, washing and vacuum drying. The process is shown in figure 1b. Again I am showing this thing. Nothing very rocket science, but only thing is that time consuming process and dilution process, adding of sodium hydroxide, adding of ascorbic acid, and ultimately will get this copper nanoparticles. So therefore people are not ready to prepare the copper. So basically people are using silver, gold, platinum and other type of ruthenium sometimes. Thank you.